Okay, so this question 19. This question 19 is about a phenomenon for wave which is called interference. When you have two or more than two waves interfere with each other, what does it mean? It means that here you have one loudspeaker, you have another loudspeaker. So the loudspeaker will send a signal, a wave, okay, to the point P here, and then it will ask the gas particle at the point P, hey, oscillate according to my signal. So then the particle P at this point will listen to this loudspeaker and going up and down, like going this way, because it's a longitudinal wave as well. So it going back and forth, back and forth, back and forth here according to this signal. But we don't just have one, we have two of them. So there's also another signal sending from the loudspeaker and tell the gas particle to move along its command as well. So it means like the P here will receive two signal to command from the two loudspeaker. And then when they add up together, it turns out that you have a minimum intensity. So what does it mean? Like for example, if the first loudspeaker, this is the second one, if the first loudspeaker asks the P, hey, jump up for an amplitude A, but then if the number two asks, hey, go down for another minus A, then what happens to the P? The P can only stay still, right? It cannot move at all because it's under the command of the two bosses, right? And then it just happened like that over time. So if you got the signal, for example, from the first, let me use some color, from the first signal like this, okay, at the point P, and then the signal of the second command, like of the second cell source, it should be this way, so then they can cancel out, okay, and that will be the minimum, okay. If they're not like this, but if it's like this, then it should be like add up together, right? And then at that time that will be the maximum intensity, but now it's this way, okay. So if you got it in this case, we call this case what? Out of phase, right? The two sources are out of phase, and out of phase means that the difference in the phase should be 1 pi, right? Maybe if you want to look up about like the out of phase, what is the pi again, so you can watch another video related to the explanation of this one. Please let me know if you need it. I can make a video for this, okay? But let's just assume that you know this one already. Sounds good? So our phase means it should be equals to pi. And how is it equivalent in wavelength? You can see this is half of the wavelength, right? Because it will need this much, right? In order to complete one wavelength, and this is another wavelength, right? So you can see, like, let's say if this is another point, like point M, and you can see that it would take this much for point M and point N to be like in sync, in motion with each other, right? Like when this one on top, this one also on top. If the one going down, this one also like going down. So in order for them to be like total in phase with each other, when they in phase with each other, the out of phase will be like just 2 pi. Then the path difference between them should be 1 wavelength, okay? So in order to have them just that 1 pi, then it just should be, what is the ratio here, right? Just cross multiply and then divided by this one, right? So that should be, the path difference is half of the lambda. So what does it mean? It means if you got the, oops, sorry, my bad. If you got the path difference of the wave, like, let me try this one, 1 wave, 2 wave, 3 wave, 4 wave, 6 wave, 7 wave, and then maybe another 8 wave. Okay, I try to make it like 8 wave to travel from 1 to P, okay? Okay, and now if we just have the same thing, because they should be of the same frequency, right? This is the same frequency. So we have another way going from number 2 to the P, but let me make the color different so we can distinguish. Let me change the color. Color. Let's make it blue. Okay. So let's say we have another wave travel from the source number 2 here. Okay, you can see there should be some path difference, right? Because from the second source to the P is longer, right? Longer by 0.6 meter, right? And in order for this one to have a minimum intensity, the path difference should be some half, right? Half of the wavelength. So if we got 8 already, then you should have, I will try to use a different colors so then you can compare. So if it just happen to have like another wave, there's no half difference, right? That will be like one wavelength. We will need another half. You see that? So for now, it will be the path difference to be one wavelength and another half, right? So the path difference, in order to have the minimum intensity, should be some half integer of the wavelength. So it could be like 0.5 lambda or 1.5 lambda or 2.5 lambda. So the general equation should be some integer n plus half times with the lambda. Okay, it could be anything. Why? Because let me show you. If you have this one move, you see there's a path difference by half here. You see it? Maybe let me highlight it for you, then you can see it better. Like for example, let me move it here. If this one is just like from here to here, is that one wavelength, right? This is one wavelength, and this is the second wavelength. We didn't finish the second one. I can finish the second one as well. Okay. So for now, if you have these two here like this, you see, if they match like that, right, there's no difference in the wavelength. But if like this, you see, it's just half of the wavelength. Can you see that? That's what I mean by half of the wavelength. Okay. So if you got the path difference is this general case. This is the path difference. Then you will have the minimum intensity, because this is when they occur the destructive interference. Okay, they cancel out each other. So let's see, the path difference here is 4.6 minus 4 meter. Let me move it here. So you can see that the path difference is like 4.6 meter minus 4.0 meter equals to some n times plus half, and then the lambda. We need to solve for lambda, right? So if you got n equal to 0, then what is the lambda? This is 0.6, right? Then it equals to like half of a lambda. So lambda should be 1.2 meter. We don't have these options in here, right? So we need to change it. What if n equals to 1? Then it will be 1/2 lambda equal to 0.6. If you solve for lambda, then yeah, you got 0.6 divided by 1/2. So lambda equals to 0.4 meter, right? Which is like 40 centimeter. So this is the option. Let's try another one. What if you got n equals to 2? Okay, so then you will got 0.6 meter equals to 2.5 times with lambda. So what is the lambda in this case? That will be equals to 0.6 meter divided by 2.5, which is like 0.24 meter, like 24 centimeter. So if in this case they have other option for you, like 24 centimeter or like 1.2 meter, then you can choose it. But here they just offer you this one. Okay, so that's the C. Okay, please let me know if you have any question. I know that it's kind of a lot because it's covered the whole topic of interference. Okay, thank you.